Welcome to Zero Knowledge. I'm your host, Anna Rose. In this podcast, we will be exploring the latest in zero-knowledge research and the decentralized web, as well as new paradigms that promise to change the way we interact and transact online. This week, I chat with Tracy, co-founder of Pluto, a company that is building dev tools that add verifiable data from web data to on-chain applications using ZK. We discuss his move from being an engineer at some well-known Web 2 companies, what prompted his move into the decentralized web, and how he eventually found his way into the ZK space. He shares the concept of web proofs and how Pluto can use and extend some of the TLSNotary stack to bring private web data into on-chain applications, as well as the future tool set that Pluto is aiming to develop. Now, a quick note before we kick off. I don't know if I've mentioned this on the show before, but I wanted to highlight ZK Mesh, a monthly newsletter that is produced by ZK Hack, another project that I'm involved in. ZK Mesh comes out at the end of every month, and in it we compile the latest research, articles, videos, project announcements, events, and much more from in and around the ZK space. It's a Substack newsletter, it's free, and it's a really good way to keep up to date on all things ZK. I've added the link in the show notes. Be sure to subscribe to get this in your inbox every month. Now, Tanya will share a little bit about this week's sponsor.
Gevulot is the first decentralized proving layer. With Gevulot, users can generate and verify proofs using any proof system for any use case. You can use one of the default provers from projects like Aztec, Starknet, and Polygon, or you can deploy your own. Gevulot is on a mission to dramatically decrease the cost of proving by aggregating proving workloads from across the industry to better utilize underlying hardware, while not compromising on performance. Gevulot is offering priority access to ZK podcast listeners. So if you would like to start using high-performance proving infrastructure for free, go register on Gevulot.com and write ZK Podcast in the note field of the registration form. So thanks again, Gevulot. And now, here's our episode.
Today, I'm here with Tracy, the co-founder of Pluto. Welcome to the show, Tracy.
Hey, Anna. It's great to be here. Thanks for having me. I'm excited to chat.
Yeah, and this has been a long time coming. I'm very excited to do this episode. We're going to be talking about Pluto. We're going to be talking a little bit about your journey to start working on this project. Quick disclosure, I am an investor in the project both personally and through ZKV in this case. And I'm kind of especially excited to do this interview because Pluto has gone through a few iterations. You know, I'm getting a chance to also check in at where it's at today. It's definitely in a space that I feel like myself and maybe members of the audience have been like looking more and more towards, kind of connected to, but not exactly, the ZK email, the TLSNotary world. So I'm looking forward to jumping in. Given that this is a new project, it might make sense for us to first just introduce what is Pluto. And then I'm going to want to find out a little bit more about you. But let's start there. What's Pluto?
Yeah, sure. So I think our broad definition of what Pluto is we want to use applied cryptography to give powerful new tools to application developers. So we kind of found while we were learning about the space that you could do so many cool new things if you just had these easy tools to use as an application developer. And it was just very hard to onboard ourselves and teach ourselves all these things. And so we want to make that easy for everybody. And the specific thing we're doing, we'll talk about a little bit later on, but we are building a technology which we call a web proof, which is a proof of internet data. So we let you add verifiable data from the internet to your application.
Nice. All right, let's do a step back and learn a little bit about your background. What were you doing before working in this space? And maybe you can share what pilled you, what got you into it.
Yeah, so my background is as an engineer. So I did a computer science undergrad and I was a software engineer for almost 10 years before this. That was like, junior engineering into senior and like staff engineering. And I did some management. I've kind of had a long journey as an engineer, and most of that was in consumer tech. Mm-hmm. Yeah. And so what really kind of like, I think pilled me on the space, or like got me at least like thinking about the space was, well, actually there's kind of two stories. So one, I had a lot of good friends in like the 2017 era of crypto who were like, huge Bitcoin fans. And I lived in San Francisco at that time. And I had these friends all like, quitting their job to go work on the Bitcoin protocol. One of my good friends like quit his job and went to work full time on Bitcoin protocol. And I also had a friend who was at Coinbase working on their security infrastructure from like 2014 to 2017. And he was telling me about how hard it was to secure the key infrastructure for Coinbase. And so I had been curious for a long time.
Yeah.
I had a third friend who was like all about Ethereum and like going through all these ICOs that were happening in 2017. It was just like, I was like I was aware of all this, and it was like a different era for sure.
But you didn't dabble? You didn't do it?
I dabbled. I did dabble, but I didn't get into the technology. So like for me personally, I didn't like figure out what Solidity was or like how to program an application on a blockchain at that time.
Yeah.
And then in 2020, I started thinking about it again. I think I was working at Stripe at the time. I had started thinking more about like financial infrastructure.
Yeah.
It was like it had been my passion for a while. I'd been a machine learning engineer, and I actually kind of had a specialization, which is I worked on pricing specifically. So I would help marketplaces price their goods. And I worked at Uber for a while. And at Uber, this is a super interesting problem because Uber prices its inventory in real time. So like, depending if there's a city, like if there's a car in a city block, like the price may go up or down depending on demand. And it was a really interesting problem and I liked working on it. And then I kind of moved from that into working on financial infrastructure. And that made me think a little bit more about things including the blockchain. But I actually had a specific moment that like pushed me fully into it, which was while I was at Stripe in 2021, when the Capitol riots happened, there was this debate internally about whether or not Stripe should ban Trump from the platform.
Whoa.
For his donation collection. And it was like a pretty hot debate. And like some people said, like, obviously, no, we're a neutral platform. Like, this isn't our responsibility. Other people said definitely yes, there are people all over the spectrum. And it was like a hard decision on the founders, I think, to come to a decision there. And ultimately, they decided to ban him and prevent him from collecting donations on the platform.
Wow.
And I don't want to get into my politics either way on this, but it did stand out to me as like a notable level of power that the technology that these companies had built over the last 10 or 20 years. And I remember like Patrick Collison, like the founder of Stripe, being like we want to be neutral infrastructure. We are neutral infrastructure. And the Cloudflare founder and others have all tried to claim that they are neutral infrastructure, but they've struggled because ultimately they have a kill switch and they have the option to do these things. And so external forces can put pressure on them to kind of change their policies and plans. And yeah, in this case, they banned him. It stood out to me, just the power of these platforms and the lack of ability to have neutrality. And I think that got me thinking about crypto more seriously.
Cool. So when you first jumped in, what were you involved in? And who were you working with?
So I actually quit my job in September 2021. And I have a co-founder, his name's Matt, and he quit his work at the same time. So we met like 5 years ago. He was building a startup. I was kind of on my own journey. And then we came together to start working in crypto. And we literally didn't even know Solidity when we started. So it was just like, let's teach ourselves the basic. Let's learn Solidity. Let's deploy a smart contract on testnet and mainnet, right? And the first project we actually did that with was this thing called Nouns, which is it's like a kind of clever community for purchasing this NFT and like building a treasury around it and then using that treasury to fund like nice public goods, like they funded a skate park and some of these things. And we had an idea that we did as a proposal for them, which was called Nouns Party, which was to like group buy one of these nouns because they were quite expensive at the time. So instead of having to like purchase one yourself, you could buy it as a group. And that was actually the first thing that we deployed to mainnet. We built this little Solidity application for that and did a grant with them and like deployed that on mainnet. And that was kind of us getting oriented and learning about the space.
Later, they did something like ZK DAO, but I'm guessing this is not the same thing. You didn't do the ZK DAO stuff.
Yeah, so we were in Nouns kind of very early when they were just getting started, and we did a proposal with them for 3 or 4 months. It took a little bit of time, but then We kind of debated, should we do more here or not? And we felt like we were kind of at our end of our arc there, and we wanted to go a little bit broader and think about different problems. So by the time that ZK noun stuff had come around, we were still paying attention. We saw it. We thought like maybe we should submit a proposal, but we'd already been through that and we decided against it. We were kind of moving forward.
What got you into ZK? At what point did you switch over there?
So after that, we explored like several different application ideas, dabbled with building like actual full businesses and products around like some of those ideas. And around like mid 2022, we kind of got inspired by, there's this group at the ETH Foundation called Privacy and Scaling Explorations, and PSE. And we saw like some cool projects that they were working on, and they really made our like gears spin. And we also saw like some of the work of Xerox Park, this like grant community inside of the EF. And yeah, we had done like a full survey of the ecosystem just to try and find like something that kind of like got us really excited about the future of the space. And now that we had kind of understood dApps and applications and like how all of that worked, we kind of like dove deeper into the infrastructure. And we have an engineering background, and like those types of problems really draw us in. And we looked across everything, like, okay, what's like, how do these rollups work? And like, how does bridging work? And how do state proofs work? And like, how does the ZK rollup work, right? How does private blockchains? And like, as we started exploring this space, we kind of were like, what is the most exciting and interesting thing that like challenges us and we think opens up like what can be built here? And that was really what started us down the ZK rabbit hole and the cryptography rabbit hole.
Okay, so this was what got you initially into ZK. I want to say that like when I met you, so this is like a year ago now, you shared with me some of your Notion notes, and your Notion notes to me are legendary, Tracy. You were the person who actually explained coprocessors to me for the first time in a way that I understood them, even though I had actually heard that description and had like met with those teams before. I may have even had them on the show before, but I remember it was talking to you where you mapped it out and I was like, I get it. I see it. I know what is happening. And from that point on, any coprocessor or coprocessor-like project that has come my way, I like had a much better understanding for it. I mean, I've seen a little bit of some of that mapping and the way that you put those things down on paper and the way you're thinking about them. Like, where does Pluto start in this story? At what point do you start to sort of like, I don't know, almost like circle the wagon on an idea that you wanted to commit to?
I think we started getting more serious about an idea around like December 2022 and like the beginning of 2023. And that was, we started to understand ZK well enough to realize like, oh, we can do general programmability in ZK. And we also saw the trend that it was getting much faster. So we were like, okay, this technology is improving. It's improving at a pretty rapid clip. If you like plot this trend out, like it's going to be orders of magnitude faster in just a few years. And so our insight was like, we should just make the highest level kind of DevX possible here so that more devs can use it. And I think we also realized it was a general purpose tool. Like it wasn't just a tool you could use for one problem. It was a tool that any dev in the space could potentially benefit from if they wanted like longer running computation or access to historic or cross-chain or off-chain state. Like there was this really universal appeal to it. We're like, oh, this looks a lot like something that should be easier to use and could make powerful applications.
So this is end of 2022. Tell me what it sort of initially was, and then it's also evolved. So I want to talk through some of those phases, because I think even when I met you, this was sort of evolving still.
Yeah, I think that it's changed. Both like our point of view has changed a lot over the last year. And then I think the ecosystem's changed a lot in the last year too.
Yeah.
When we started focusing on this, it was like, all right, let's make something that every app dev in the space can use. So, there's a bunch of app developers. None of them are using ZK right now. It's mostly like being used by rollups and like some, in a settlement capacity. Can we give this tool to an application developer? And like, what's the benefit of that? Is there benefits to that? And we pretty quickly realized, yes, we could build a tool that did that for an app dev. And so that started to look like this concept that others have called a coprocessor, but the space now knows as a coprocessor. which is sort of off-chain computation. And we started to build a service for off-chain computation in actually using Solidity. And that was kind of where we first started getting serious about like, I think there's something here. And really, the idea is a simple interface for programming a snark for long-running computation. And we think like access to things that aren't currently possible in a Solidity programming environment. And so that was, I think, where our heads were at when we met, probably. That was April 2023, I think, at Gevulot. And we were just kind of mapping out the space at that time. That's probably why I had so many Notion docs of like, okay, what? I kind of do this thing. I work I work top down, but I also work bottoms up. So I try to have like a top down map of the world. Like, what does the world look like today? Who's exploring the edges of the map? Like, what are they doing? Right. That's sort of my top down view. But I also try to work bottoms up. Like, okay, I'm going to write some code. I'm going to understand how this works. I'm going to run it. I'm going to see what the performance is. And then I try to like meet those two in the middle a little bit.
Whoa.
Like, okay, here's what the code can do, and here's where it fits in the world, right?
Oh, that's interesting to think of that. Yeah. I feel like I'm only seeing the top down most of the time, like, because I'm not an engineer. But that's really cool that you get to also see it from the other side. I think I'm just like, I often have to ask people what's happening, under the hood to get a better sense for it. You get to look at it.
Yeah, I think a lot of great engineers I know actually don't do the top down. They only do the bottoms up. Oh. So they just are in the code and they work bottoms up to try and understand like what a tool is capable of, and they try to experiment bottoms up. That actually leads to a lot of really great discoveries because you're instead like in your more creative mode and you're sort of like exploring for yourself what can be done. Top down is also useful because I think it is good to have some perspective on like how others are looking at these things, but it can be like limiting if you only look that way because you might just try to fit yourself into a box that already exists.
There was a point where we checked in and you had sort of described Pluto as a little bit of a like Solidity extension. I want to understand if the project today still has that aspect, and maybe you can share a little bit about what you meant by that, being a Solidity extension back then.
Yeah. So what I meant by that is like, if you think about Solidity today, it's a multi-entry point program. So you can like call a program and start from many points. And each sort of entry point in that program has a certain capacity of logic you can run, like 250 to 500K gas, something like this. There's like a fixed amount of compute you can do. And it's a really bounded box. And we experienced this when we were trying to make dApps. It's like, there's a very limited amount of things that we can do inside of this box. And I think that's a barrier that anybody who tries to build an application like runs into pretty quickly. It's like, okay, this is what I can do. This is what I cannot do. And we started to view cryptography and also ZK as like tools that can grow this box. And the first idea we really had, because I think we had some background applications, was like, what if I could just like run 10 million gas or 50 million gas? Like, would that be a useful addition to the toolbox here? And I think we got kind of inspired, like, oh, that would be cool. Like, that'd be really powerful. And we thought about some infrastructure use cases, like, oh, if I could do 50 million gas and it just like is programmable like Solidity, I could verify like hundreds of signatures and then make a succinct commitment to hundreds of correct signatures. And that would probably be useful for like a validator set, checking a validator set is correct. But there's also non-infrastructure things like maybe I just want to like compute a Merkle root, like to generate a snapshot, like who owns this token? And I want to add them all to a Merkle tree and then get the Merkle root at the end. And we're like, well, that could be cool too, because then you could snapshot something trustlessly, and a lot of other things like started to feel interesting there. We also thought down the privacy rabbit hole a little bit, like, oh, you could add privacy and like, a UTXO tree with notes into Solidity. And if you had a like unbounded gas, you could encode this note tree and access it and nullify it while saving gas costs. Yeah, and each of these just started to look like tools that I would want if I were building an application. And so our head was like, if I'm building an application, these tools can exist. Like, why don't I have these tools available to me right now?
Yeah.
And I think that that was what got us excited. It's like, let's bundle this up in a way that everybody in the space has these tools readily available.
Would you say that's still what Pluto is today? Or has it changed from that? Because, yeah, I feel like at least the focus from speaking to you more recently seems to have narrowed at least. Because what originally was this Solidity extension, the way I understood it was almost like in a coprocessor-like environment, you had these extra things you could do in Solidity. It would kind of go off-chain, something would happen, it would come back on-chain, but it would extend it somehow. But that it was quite general purpose. What happens after that?
Yeah, we went down that path a good amount, and I think we still have a lot of interesting ideas to eventually bring to bear. But we started feeling kind of like we didn't want to go in a hole and just like try and invent a vision for a better future and then come out in like 2 years with like, here's the new execution environment for crypto. You know, like we wanted to kind of like inch our way into it a little bit more. Partly, I think it's just like about how we learn to build products. It's like if you're not shipping product at like a rapid clip, like you're not learning and you're probably like detached from what people actually want. So we kind of used that initial North Star to help us learn about cryptography. And so we grabbed this ZK EVM off the shelf that PSE had built, and we grabbed this like snark compressor that Axiom had built. We kind of like started tinkering with these things and seeing how they fit together. And we did build a system that roughly does what we described, not with the best performance. And we were kind of like running into some performance issues. And then we started building a better version with like Plonky 2, which is the Polygon stack, which is much more performant than Halo 2 for these things. And we were seeing good performance, and we were like, I think we could ship this. But it was just such a grand vision and like so many big ideas baked into that. I think we started to think like, I had a few conversations with people about this sort of like grand idea. And we were like, it's too general, it's too grand. Like, what is a very specific thing that people, instead of having to like learn our new way of thinking, can like benefit from this one specific technology and maybe get the most interesting bit of what we're trying to add. And then we can maybe work our way into the grander view over time.
So now sounds like a really good time to talk about that specific case. And I guess this will also share with our audience kind of what Pluto is today. What are you focused on? What is Pluto?
Yeah, so we are about to launch what is called a web proof. And this is like a term that we kind of invented, but we think it like captures the idea, which is a proof of arbitrary internet data. So we kind of started focusing our thinking toward like areas that were underexplored but powerful. And that included bringing data from elsewhere on the internet into blockchains. And we do this already today with like oracles, but they're in a pretty fixed and static structure. They're not very programmable and they're not very flexible. They also can't collect personal data. We can dive into some of the limitations of them, but we kind of started getting excited about like a bit of a smooth brain kind of like idea that you get when you first come into crypto as a developer. You're like, I'm building an application. Okay, I want to get the weather in my Solidity contract. Like, how do I curl the weather API? And then it like doesn't make sense. And you're like, why can't I get the weather in a blockchain? Like, that doesn't make sense. Obviously, it's a bit of a like smooth brain way of thinking because, okay, you start thinking about blockchains. And then eventually, like, for us, after we like had learned all about this, we like kind of went back to that, like, why can't I get the weather in a and I think that we were like, well, maybe that is interesting. Like maybe that actually opens up some cool things that aren't possible. And I think we took some inspiration from like a few teams who were starting to think in this way. Like we saw ZK P2P, for example, and they had built this really cool application that lets you use your email to verify a Venmo transaction. And it was kind of like starting to merge these two worlds of like, you know, blockchains as they exist today and the internet and its usefulness as well.
For sure.
And that really, I think, scratched our itch, especially given our background.
Yeah. Here, we'll put this in the show notes. We actually did an episode with ZK P2P, but also it's like ZK P2P is built on ZK email. And that's also coming out of PSE. But what you're describing also sounds a little bit like the TLS Notary project, but I actually have never dug that deep into that, so I might not be like fully following that. Can you tell me if it is, like, first, what is TLS Notary, and then if it is similar, or if you're like extending it, or if there's some connection there?
Yeah. So TLS Notary, I believe it's got a long history. I think it's like a 10-year-old project or something. I haven't fully dived into the history, but I think this started back in the Bitcoin era. In the last few years, PSE has rebuilt TLS Notary in Rust with more modern cryptography techniques.
Nice.
And really what it is, it's in the name. It's a TLS. And so what TLS is a secure communication channel between computers over the network. So
which exists already, like on the internet.
Yeah.
Yes.
We use it all day, every day, right?
Yeah.
You see the little green lock, like you're using TLS or SSL. You're essentially initiating a connection with the server, and that traffic is encrypted. So when you send your credit card or your password, like nobody else on the internet can see it. You're just in like an encrypted relationship with the server. So that's TLS. And then the second part of the name is notary. And a notary is somebody that sort of authorizes a document, right? And in this case, this software is acting as an authorizer of that connection. So it's sitting external to it, and it's sort of putting its stamp of approval on it that like, oh, this connection between these two parties, the server and my laptop, did play out, and it actually transmitted this data over the connection. And what that does is it lets you verify the actual contents of that connection.
So then is Pluto also playing in that world? Because you mentioned web proof, and this sounds similar to what at least TLS Notary might be used for.
Yeah, definitely. I think we are trying to generalize we're actually actively using TLS Notary and making some modifications to it. And I think we're trying to generalize it and make it easier to use inside of an application that might actually live on mainnet. The current code base isn't audited. There's performance issues in the current structure. So I think the team building it is actively working on that, but we're also starting to think about some of how we like contribute publicly and like help level up that infrastructure. But it also comes with challenges productionizing it in many ways. So one way is just to audit and security, but another way is you're actually communicating with this notary in real time while you're connected to, like, say, Amazon server, which I was using as an example. And so latency becomes an issue. Like, how far are you from the notary? And you actually want to have like a notary hosted close to where you're connected to Amazon so that you can minimize the latency for it to sign these transactions. There's a bunch of little details about how that works that make it difficult to use in like an application today. And we're trying to sort of like fix those issues and make that easier for application developers.
So to understand this, I think we should kind of try to imagine from like an end user's perspective. And I realize that you're building tools that maybe a developer would use, but I still want to understand like how someone could use something like Pluto or something like what you're building to actually create these web proofs, and what those web proofs would even enable.
Yeah. So there's a couple different ways that this can be used. So I think the easiest way to think about it is just similar to an Oracle today. So let's imagine I want to just get a price from CoinGecko. Like, what is the price of Ethereum today? Now, an Oracle network does this by having a collection of parties all go get the price at the same time, and they compare, they make sure they agree, and then they spit out, with some variance, this is the price of ETH from CoinGecko. How you could do this in a web proof or with TLS Notary, you can actually have just one party retrieve the information and then use a process that verifies that that one party got it correctly from CoinGecko's server. And in doing this, it becomes essentially like a more powerful Oracle that doesn't require multiple parties to retrieve the data. You can just retrieve the data yourself. And that's sort of the standard public Oracle data example. But this actually, because you are the only party having to retrieve the data, it can actually go a bit further than that. So it can also be used for retrieving personal or private information. So instead of an Oracle network, which can only get public data, this could retrieve things about yourself. So it could retrieve your bank balance or your place of employment, or maybe the fact that you own a Taylor Swift ticket on Ticketmaster. Facts that you would have to share your API keys or your password with the Oracle network in order for them to get. And so this becomes pretty powerful for a wider range of internet data than what oracles can do today.
What is this? Is this the TLSNotary or is this Pluto?
This is enabled by TLSNotary, and we depend on TLSNotary.
All right.
And what TLSNotary does is it lets you verifiably retrieve internet data. So it takes standard internet data. I'm going to get data from CoinGecko, and it makes it signed internet data. So I'm going to get data from CoinGecko, which has a signature on it that says this data is correct.
Cool.
This actually does not use ZKPs. It's just transforming the internet into something that emits signed data instead of unsigned data.
Got it. Okay, and then what Pluto is doing, let's go from there. So it changes it because it allows you to go into like private or like owned, like things that are not public data.
Yeah, so the things that we add on top of this are we make it easier to use in an application so that it's deployed in a bunch of different places. It has lower latency. It scales a bit better. But we also add a ZKP on top of this. So in the notary example, it's just emitting signed data. So it has, the back and forth between the server and the client. So, hey, chase.com, give me my bank balance. Yes, here's your bank balance. It's $10,000. Okay, thank you. And it's got this transcript that has been signed by the TLSNotary process.
Yeah.
But this is just signed data. You have the plain data and you have a signature over it. Now, there's a little bit of details I'm not going to get into about how TLSNotary conceals some of the facts in there. So it actually has what's called selective disclosure.
Okay.
So you can selectively disclose some of the data. But all of that is non-ZK. Like it's using a technique called garbled circuits and key sharding in order to do this. And where we come in is we actually encapsulate that proof into ZK to make a ZK proof, which makes it more succinct. But we are also adding some capabilities on top, like the ability to do some computation. And we also make an SDK that lets you collect user data as well. So if I need to collect my personal data, say my bank balance, in order to do that, I have to be logged into my bank. I can't just say, Pluto, collect my bank balance, because Pluto doesn't have access to your bank balance. So there's actually a user experience here of I log into my bank so that I can retrieve that bank balance in a verifiable way.
And when you say log in, you're just you're talking about logging in on the web in a portal. Like you have to be on the page. And then on the page, you can create this proof and then privacy of the underlying proof in a way, or what the proof is proving. Yeah,
that's exactly it.
Okay.
Yeah, so you actually have to pop up a panel that you input your data into, and it all lives on the device. It never goes to our server.
Interesting.
And we collect that data and then ultimately get a proof, and then we build a ZK proof over that. Now, day one, we're actually building the ZK proof on our server, but we actually think we'll start, by the time we get to mainnet, we think we'll be doing it on the device itself.
I want to kind of bring this back, though, to the Solidity extensions, because it feels very far away from that now. And I also don't even know where there's a blockchain in here. This seems more like a web technique with a ZKP, but you sort of said that the Solidity extension idea and those tools, you had narrowed it. So what do the tools even look like? How are they working?
Yeah, so right now this is just an SDK for adding internet data to a blockchain application.
Okay.
It's a very specific thing for just adding internet data that you maybe otherwise couldn't add to your application in a few lines of code. And this, to us, this is narrower because I think when we were thinking about this Solidity coprocessor, we had started to think of it in a very expansive way as a new developer experience for crypto.
Yeah.
It's and if you start from first principles and you try to imagine what is a better DevX for crypto, given we have cryptography and a bunch of tools available to us, what is that DevX? And where our heads were at is, well, it has long-running computation, meaning I can write a script that runs for a very long time and still get a succinct commitment to it. It has potentially privacy preservation. So maybe I can store state in a privacy preserving way. It has state proofs probably. So like I can access historic state. And it also probably has what we're calling web proofs, which is access to internet data or sources of data that I normally can't retrieve in a blockchain. And so in our broadest vision of what that Solidity thing was, it included all these different tools for being like a superpower blockchain developer. Like no longer was I just writing 200 to 500K gas of Solidity code. Now I had all these tools at my disposal and I could write these really rich programs that composed across all these tools. That maybe is like part of our grander vision for how the DevX of crypto becomes this more evolved thing. But the narrow point of it is, well, what about just Oracle data for the internet?
And just the web proof side of things. So that, okay,
Exactly.
So you're not doing computation on these in this current state. Like you just focused on the bringing of these personal information from a web browser directly to an application running on a blockchain.
Yep, exactly.
Okay. And this is all on Ethereum, I guess. So it's still like, is it still Solidity? Like you're still formatting it to be used in Solidity?
Yeah, you would still verify the web proof in Solidity and you would use it, in a dApp that is written in Solidity. Okay. And you would verify it on ETH or on an L2, any of the traditional places. But right now it's sort of just an attestation. It's just like a fact, one piece of information. And you can contextualize that on chain. But right now there's no way to contextualize it in a coprocessor or to do like, I'm going to get my bank balance from Chase and I'm going to get my bank balance or my 401k balance from Fidelity and my brokerage account and add them. Like you can't do that right now. And so that's where we're starting.
Okay. But that's like where you'd like to go, I guess, is that you could add them.
I think it's technically possible to do that. And I think we are starting to figure out if that's where we want to go.
Got it. Would you say that just doing this web proof, though, would you still kind of put yourselves in the category of a coprocessor, but just a very narrowly focused one? Or do you think it's something else now?
I don't know. I haven't actually used the coprocessor term a lot to describe us because I found it confused people a lot when I would use it. So I don't know if people know what a coprocessor is. Like I don't know if there's like an agreed upon definition of a coprocessor. I think one way you could think of it is like, something that does computation prior to the transaction being settled on chain. And so, and it does it in a ZKP probably, right? And because it's a ZKP, you can maybe do this like on demand, sort of like while the application is needing its data, it can compute a coprocessor proof as well. But I think the ecosystem is still trying to digest like what that means. And there's like some, thought pieces on like, well, a coprocessor can only do synchronous data and like they can't be ordered. And like there's a bunch of like brain damage around how to do this and what this means. And I think I don't really want to like try and categorize us into this. It's like we just make these proofs. We make these proofs of internet data. You can use them in your application. That's what we do. And I think we will probably think more generally about that over time. And like, how does making these proofs of internet data become a more general system for programming in blockchains? We are thinking down that path.
Yeah.
But I don't know that we're going to try and like categorize it as a coprocessor or any of these things. We're still trying to figure out how we categorize that and how we communicate that, because I think developers will need to understand this thing very clearly and what benefits it gives them. And so we want to try and do a good job of describing that when it comes time.
It sounds a little bit like the proposal that Mina or the O1 Labs folks make, which is around this like ZK app. And I remember them using language. And they didn't say web proof, but they would have said something
Maybe they said like ZK oracles or something.
Yeah, it definitely had sort of that connotation of like taking web information and using ZK. So I just wondered if you'd looked at that or if you're familiar with it, if it is similar or if it's actually something else.
Yeah, I think this idea has been around for a while. I'm not sure exactly who invented it, but like I was saying, I think TLSNotary's been around for years. And Mina, I think, has talked about ZK oracles, is I think what they've called them for a long time. I'm not super in depth on Mina's approach, but I believe they are also considering a notary approach. So this would notarize the connection in the same way that TLSNotary does. I don't think that they have a custom implementation of this. So maybe they do, and I'm just not familiar with it. But yeah, I think for the Mina ecosystem, they also believe that like access to arbitrary Web 2 information is useful for their applications. And so I think they are either working on building or want someone to build this ZK Oracle, which would let you retrieve things like your bank balance and use it in an application. I mean, we are focused on Ethereum first and foremost. So, and we're kind of a general purpose tool for developers, kind of decoupled from any specific programming language or any specific blockchain. I think we also add the user experience side of this as well. So we had a couple things on top. We had the user experience side of actually being able to collect this information. And we had the developer experience side of actually being able to link it into a smart contract application. And we add like proofs on top of it that verify and retain the privacy of this whole process. So we kind of bring it from like an idea in concept that people understand to like you're going to actually be able to use it in a smart contract application on mainnet.
Do you think the proofs that are being generated, are they going to require some sort of proof of marketplace? This is a term that's obviously been floated around a lot, but like who are generating these proofs? Do you imagine you guys doing it for now, or would this be something decentralized? Like, are you going to work with one of the existing prover networks or proposed prover networks? I don't know actually if there's any like really live ones yet.
Yeah, so I think for our testnet, we are going to generate these on our server. And we're still coming up with the strategy for like the plan for mainnet. My expectation is these are largely client-side proofs. So they'll be generated on a user's device, and the device will emit a proof text that can be verified on chain. But you could be in a scenario where you have a lot of these proofs and they kind of go into a holding pen, and you want to aggregate them before going on chain so that you can lower the costs of everybody. That could potentially be done in a prover network, or it could be done on a central server. I think my general stance on prover marketplaces and prover networks, I think they're exciting and they're interesting to think about. I do think we're a little bit early to that. I could be wrong. I'm open to being wrong on this, but I kind of plot the trajectory of rollups and their journey to decentralization, right? And if you look at rollups kind of coming to testnet, mainnet in 2021, it's taken years for them to like work their way towards decentralizing the sequencer and even having fraud mechanisms, right? And here, two years later, we just barely have a fraud mechanism on testnet in Optimism's case. And it's going to take another 6 months, maybe another year before that's on mainnet. And then I think the journey to decentralized sequencing is even further out, and the journey to decentralized proving, I think, is even further out. So I think it's a long journey, and we are kind of setting up the proving infrastructure for this already, and it feels we're a little ahead of where the system is. But I do think over a longer time horizon, these things are probably important.
So you sort of mentioned a little bit of the ZKP stuff, and it's Plonky too. Is there anything else under the hood that might be interesting to our listeners in how in like kind of the systems that you used or how you built it?
Yeah, so we didn't want to reinvent the wheel. So when we first started working on this, we worked in Halo 2. Well, I guess one thing I'll add is all these systems aren't audited necessarily, right? So there's a lot of like frontier things being built. Like you've probably heard of Jolt and Plonky 3, right? And there's even like Lurk, which people I think underestimate. I think Lurk is really cool. But a lot of these systems are still in active development. They're not ready to go to mainnet, right? And really the few systems that we have that are really ready for mainnet are like Halo 2, maybe Plonky 2, maybe Narc, and Circom. And like those are the set of tools that you can use and have some confidence in mainnet that they've been audited. And then I guess more generally, how we've kind of worked on ZKPs up to this point is grabbing other people's tools off the shelf and trying to leverage Halo 2, Plonky 2, and benefit from some of the existing technology there. But I think as we start to pursue more performance, for these client-side proofs, we might find ourselves doing some sort of custom app-specific snarks in order to get us the most performance.
I also wonder if you're doing it client-side, like, does the proving system sort of, I guess you need performant in a certain way, but maybe all of the things you listed, I think, are pretty like snarky and not starky. Like, would you ever go more on the starky side? Actually, well, are they? Maybe these are mixed. Like Plonky 2 might be like a bit of like a weird mix one, eh? Yeah.
Nowadays it's a bit complicated. Like we used to have maybe a clear line between the two, but Plonky 2, Plonky 3, these use starks for part of their proof, and they use snarks for other part of the proof, and these things are getting mixed and matched a little bit more. We, in terms of like pure stark stacks, like maybe Cairo, we've dabbled with it, but we haven't been serious about using that. Things are evolving really rapidly. I would say like one dictum, like one way you could make this decision in the past was about performance and proof size and privacy. Like these are the sort of the like criteria you could try to make a decision. And so if you plot these things on a performance scale, some create like a performance by size scale. Some are very fast, but create very large proofs. And that's typically like Starks, but that's also, say, Jolt and Plonky 3. They're like large proofs. They're made very efficiently. And other tools like Circom and Halo 2 can create very small proofs like Groth 16 or single column or a few column Plonk proofs that are very compact. They can be 4 kilobytes or down to 200 bytes in the absolute most extreme case. And there's a trade-off in terms of performance and the size that you get out of these things. So it ends up being a pretty complicated trade-off space to try and choose the right tool for the job. And then if you add a third axis, which is privacy, like some of these tools are privacy preserving, some of them are not privacy preserving. So you kind of end up with a somewhat complicated trade-off space. In addition to that, like the trade-off space is changing. So in the past, it maybe made sense to only verify a proof that cost up to 500K gas. But now we're starting to see a world where maybe large proof verification without compression is doable. And we might have contracts that can verify millions of gas of these larger proofs. And so that trade-off point is also moving as well.
Why is that? Is that the hardware is the answer?
It's not necessarily hardware. It's more about gas costs in L2s, and with blobs coming
L2s.
online, right? Gas costs are going down in L2s,
just
right?
like it's not a limitation. Yeah.
There's still some limits, but the ceiling is lifting a little bit. And so we could end up in a world where it's not so crazy to verify a proof that is, costs 4 million gas to verify. And in that world, you may make a different architectural decision about which types of proofs you use because that cost has gone down.
I see.
Yeah. And on that performance axis, there's both compute time, but there's also memory budget. So like if I'm on a server which has a ton of memory, running a Plonky 3 proof that uses a lot of memory is totally acceptable. But if I'm on a mobile device, then I have a memory ceiling. And so I think a lot of the space is sort of like navigating this sort of 3-dimensional trade-off space and trying to figure out like what is the exact tool for the exact problem that is optimal and gets me all the things I need, right?
For sure. And it's like, which environment is it working in? Is there going to be a hardware element, or is it going to be on one of these L2s? How fast, how expensive? That's interesting.
We've kind of gone down the rabbit hole on all these things as well. And I think we're keeping up to date, and we're trying to kind of like navigate it correctly and make the right decisions along the way.
How hard is it in your system to switch these things out? Like, I know that right now it's still kind of being built, so you have flexibility. But yeah, is there a moment where it freezes, or can you create something where you can like switch these things out later?
Yeah, I think if preserving optionality is super important, you could technically architect a system where like, you can generate proofs in many different ways and have a verifier you have different verifiers that are sort of flexible over the proof system. Like these things are technically possible, but it's not obvious to me that like you're going to want that system in production. I think probably what happens is you get to a good enough proving system to solve the needs of your stack. and then you kind of commit, and like it becomes your proving system for a year or two in production. And only after like the space has dramatically changed, the unit economics of proof generation, would you like build a new version and iterate forward to it. And I think this is what we've seen rollups do as well, right? Rollups start on one proof system. And now if you look at most of the ZK rollup guys, they're like in the process of working on their V2 or their V3, which has a newer, more performant and less expensive proof system.
Yeah. What stage are you at? That's kind of like, now I'm kind of curious, like how far are you from potentially choosing one of these things? Or are you on testnet? Are you what can people already play with?
Yeah, we aren't public yet, but I would say we internally have a testnet. We're going to like launch that over the next few weeks here. So I think we'll have a demo in public before the end of this month. People will be able to go play with it. And shortly thereafter, we'll have a testnet that people can actually start building into their applications. We have a lot more to come after that. This will be our first launch, and we're sort of like building a bunch of really cool things that can come after that.
Very nice. So it sounds like this is, I'm just going back to your background and those first forays into the space and finding the tools kind of lacking, and you've stayed sort of on that tooling front. It sounds like this is kind of like one narrow but potentially powerful tool or tool set that you've developed. There are also other teams building tools. I'm sort of curious, like kind of just, throwing back to that larger, like what's out there, how possible is it that we get closer to that like actual decentralized transfer thing? I'm assuming there's other tool builders as well. How far along do you think we are? How long do we have to go? Like, do you now see momentum? Do you think that like we are getting closer to that future that you sort of envisioned, or do you think we're like still very much at the beginning? And I guess the question actually goes to both like general blockchain applications, but also, and maybe separately, we should look at like ZK. But let's start with the blockchain application side of things.
Yeah, to be honest, I think we're a little bit stuck in a rut, like with the current set of capabilities. Like if I look at when I did this survey of the ecosystem and I tried to think about like what comes next, a lot of what people were thinking about was how do we take the 250K gas Uniswap swap and make it lower cost, cheaper, put it in more places, higher throughput. Like that was all about taking what the like one great application that we all were excited about was, right? And like, and just making it cheap and global and universal, right? Yeah. And now it's like, all right, so we've got all these roll-ups and like all these approaches to decentralizing them. And like, we are going to get like 1 cent Uniswap swaps, right? And I think that's cool, but like, and I think it's important, but for me, like when I think about what excites me, it's not lowering the costs. Like if we just lower the costs, like that's not innovation. Lowering the costs is about unit economics, right? And it doesn't bring novel, creative experimentation and new applications into the space. And so I think when I look at a lot of what's happening in blockchain infrastructure, it's really great work on lowering the costs of Uniswap swaps.
Wow.
But what is the thing that expands that design space, right? Yeah.
Wow.
And I think that's kind of where I've tried to orient my mind is like, okay, everyone else is going to lower these costs. These costs are going to come down over the next few years. Like I can bet on that. And then like, what does it look like to expand that design space beyond Uniswap swaps, right? What does it look like to add web data, add historic state, add long-running computation, add privacy, and like, what does it look like to build a developer experience that has all those things baked in so you have a much richer design space for building these applications? And so, I've tried to keep us focused on like open the design space versus lower the costs.
Yeah, I mean, I think what you're saying makes a lot of sense here, and I sort of appreciate you sharing this perspective because I think I also would like to see us just really expanding our thinking and how far we can go with what we're doing. I think the way you just put it, like the one use case and then like just optimizing for that thing is really well said. I hope we can do better and bigger and more. Yeah.
And I don't want to like criticize. I'm not trying to criticize. I think people are doing great work. But yeah, like 80% or something of the investment dollars in infrastructure are going into lowering Uniswap swap costs almost. And
Wild.
like that is a useful thing. But just cheaper transactions, I don't think are going to like 100x the space. I think you need to solve like Sybil resistance, right? Like anti-Sybil techniques, and you need to solve identity, and you need to solve privacy, and you need to solve access to Web 2 data, right? Like all of those open up the design space. And
I can tell you've been hanging out with DC Builder because you just mentioned
I
civil
mentioned
resistance.
identity. But I actually, I think it's one of the most important threads, actually. I gave a talk at ETH Denver sort of about this topic, which was like how LLMs and sort of like AI in general, generative AI, like changes the internet and the implications for the internet.
For sure.
And I have become pretty convinced that like KYC mechanisms and CAPTCHA mechanisms, like they're going to struggle. And like we're going to end up with a Twitter feed that is full of generated content.
Yeah.
And is that what people want? Like how much will you value a stamp that says this is human when like the whole feed is generated?
Yeah.
I think it's going to be very important to you as a user of the internet, because like there's something about just knowing it's not just generated text.
For sure.
I mean, maybe we end up in a world where we all have just purely generated feeds and we're just okay with it. But yeah, so I think that digital identity string is really interesting. But I also think like merging Web 2 data into blockchains is also like one analogy I use is like if you look at blockchains as like a percent of valuable state on the internet, how much of our valuable state lives in blockchains today? And it's just a
Not
drop in the
much.
bucket, right?
Yeah,
a tiny
yeah,
amount.
yeah.
And if you look at how much valuable state lives in other databases owned by Google or your bank, right?
For
Almost
sure.
all of it. We have this tremendous wealth of information. And like if we can bridge these two worlds together, I think you get a more creative set of applications.
That's cool.
Yeah, maybe I'll add one last thing, which is we've kind of like been thinking about this idea, which is what we call gray markets. And a gray market to us is it's like not a black market. It's not like a white market. It's like in between, right? And if you can kind of like bridge these two worlds of data, you can start to make these marketplaces on top of the existing infrastructure. And so I think ZK-P2B kind of did this with Venmo. They made this peer-to-peer off and on-ramp on Venmo's transaction capability. But you could also do that, say, with Ticketmaster, where you use Ticketmaster's API to create a marketplace for ticket repurchasing. But you can do it on video game assets too. So I could like have Counter-Strike skins and maybe trade them for World of Warcraft gold and like build a marketplace around that. There's a bunch of like these marketplaces you can make for digital assets that aren't blockchain native digital assets. And we think that like starts to get really exciting.
And it crosses these like databases, it crosses companies. And whereas like I think like a third party company would have a really hard time doing that, primarily because you'd need to get like licensing and agreements and all of this stuff, because this is sort of like so internet native. It's dependent on it just like existing in your browser. You start to be able to do more stuff. Maybe.
Yeah. You can
I hope they don't try to block everybody. That's the only thing as I say this, I'm like, or those companies will still try to lock this stuff down. But
Yeah, maybe it creates the conduit toward like a new kind of protocol for that type of marketplace. It helps kind of bridge the gap in the short term, and then the long term, it grows a new network that can flourish on its own.
Wow. That's really cool. Nice, Tracy. Thanks so much for coming on the show, sharing with us a little bit about your journey from, being a Web 2 engineer to the Web 3 world, to like getting into ZK, to exploring, teaching me coprocessors, developing Pluto. First, it's this like Solidity extension, or like, kind of like a generalized tool set, narrowing it down to this web proof story. And thanks for sharing what that could then enable. It's very exciting.
Yeah. Thank you. It's been a journey. I'm excited to continue.
Cool. I want to say thank you to the podcast team, Rachel, Henrik, and Tanya, and to our listeners. Thanks for listening.